I wanted to show you something called a resonance structure. What this is when I draw the Lewis structure for this, there's going to be two possibilities. So I just want to start showing you, and then I'll kind of explain as we go what a resonance structure really means. So the Lewis structure, we're still going to do the same way, where we figure out the electron cache. You have nitrogen and oxygen. We know that nitrogen has 5 valence electrons. There's one of them. So that's going to give us 5 electrons. The oxygen has 6 valence, and there are 2 of them, which is going to give us 12 electrons. So this gives us 17 electrons for the cache. And right away I know that there's a problem there because this cannot be an odd number. It always needs to be even. And I forgot that this is the nitrite ion. So it is -1. It's a polyatomic ion, so these all together have a -1 charge. -1 means it has 1 extra electron, so I'm going to add 1 to the cache. If it had been -2, we'd add 2. If it was +1, we'd take away 1. So now we have 18 electrons. This is our cache. So what I'm going to do is I'm going to think about the bonds. So I've got 3 different things here, so a minimum of 2 bonds. And remember, every bond is going to be represented with a line, which is really going to be equal to 2 electrons. So 2 bonds would be 4, so we're going to subtract 4 electrons from the 18. And that gives us 14 electrons. So what we're going to do is we're going to draw the nitrogen and the oxygens. There's my 2 bonds that I just subtracted right here. And now these are the electrons that I'm going to place around the atoms. So I can put 2 here. So there's 2, 4, 6, 8, 10, 12, 14. So you don't want to go over 8. So you can see that this oxygen right now has 8 valence electrons. So I wouldn't have wanted to put another pair anywhere around the oxygen. Same with this one. The nitrogen has right now 2, 4, 6 valence electrons. So it's not fulfilling the octet rule. So what will happen is there's going to be a double bond. One of these pairs of electrons is now going to be shared between the nitrogen and the oxygen. So this is no longer here. This oxygen is still fulfilling the octet rule, 2, 4, 6, 8. This nitrogen is also 2, 4, 6, 8. So everyone's fulfilling the octet rule. So this is one of my possible resonance structures. I'm going to put brackets around it because it is an ion, and I'm going to put the oxidation number or the charge on the outside. Now, these electrons could also be here. So really, the electrons in the bond can be between the nitrogen and this oxygen or between the nitrogen and the other oxygen. So in reality, there's something called localization where these electrons are evenly found. So it's like an average, and the electrons are just kind of going between both of the nitrogen in this oxygen and the nitrogen in this oxygen. So to show that on paper, we draw another resonance structure. We draw an arrow with 2 arrowheads, and now I put the double bond in the other place. So by drawing both of these, I'm showing that the electrons are really found kind of equally between these 2 bonds. So this extra pair of electrons are going between the nitrogen and this oxygen and between the nitrogen and this oxygen. So I don't have to recalculate the cache or anything. I just need to think about, okay, if the double bond's here, that means this oxygen only has 2 pair of electrons because it's fulfilling the octet rule. There's 2, 4, 6, 8. The nitrogen, remember that pair has to be up here because now it has 2, 4, 6, 8. And then the oxygen has the other 6 electrons. Again, it is an ion. And this, by drawing both, I'm really showing that the electrons in this double bond are equally found between the nitrogen and both oxygens.